Hi folks, this is Sarvji Johal coming to you from Mobile World Congress 2026. Today we're talking to Mark Hughes from IBM. I will ask for his introduction and we'll get into the quantum safe related discussion. Hey Mark, thanks for joining me today.
Thank you.
Thanks for your time. And please introduce yourself and then we will get into the discussion.
Well, Sarvji, thank you for having me. I'm Mark Hughes. I'm the Global Managing Partner of Cybersecurity Services at IBM. It's great to be here.
Thank you. This year's theme from the main keynotes have been 6G. In the context of quantum, how do you see the quantum merging with 6G from one side and the cloud is maturing from the other side as well? We have HPC coming from likes of NVIDIA and likes of Google. Like we will have a lot more compute in different shapes and forms, and quantum being not the classical computing.
Yeah.
Are there any safety concerns when the quantum enters the sort of field? Like the one big concern is the quantum safe.
Yeah.
Right. So please shed some light on that. Like what progress IBM is making, and also what progress industry is making in general to keep our systems safe.
It's a great question, and I think to tee this up, you talked about 6G considerations. We had a lot of security when we first introduced even 4G and 5G, and how we thought about security in that context. And so, a lot of that remains very, very relevant. But quantum is, of course, the next frontier. And as we sit here in front of System 2 or a mock-up of System 2, I mean, it's incredible. What a privilege to be here and with that in the background. And here at IBM, we're right at the forefront of what's happening in quantum now. And so really what I see is the quantum is going to become part of that spectrum of computing. So we'll still very much have our traditional classic compute. We'll have our GPU compute, which obviously is fueling a lot of what we're doing in AI. And then quantum comes into the fray as that comes online, as it will do in the coming years. And when I say that, in the next few years. And within that, really, the obviously the approach that quantum computing gives us is very different from classical computing, as we know. But one of the areas, and there's really three areas that we think about in IBM that quantum computing is going to really fuel. One is around life sciences and being able to sort of mimic nature and all the possibilities that quantum computing unlocks from medical and other things. The second is being able to really conduct much more efficient search, and that has a huge applicability across the data sets that we as organizations run all day, every day. And then the last area is really being able to solve for very complex algorithms, which we can't solve for today with classical and GPU compute. And it's in that area that there is a specific use case where there is an algorithm that has been around since the 1970s, so-called Shor's algorithm, which means that the traditional factoring that sits within asymmetric encryption, once that algorithm can be executed, and we see that quantum computers will be able to execute that algorithm, it's going to mean that our existing cryptography that we use today is going to be vulnerable and liable to be able to be cracked, essentially.
Yeah, actually, I have heard sort of conflicting point of views that the security concerns are overblown, or like are there really big concerns? Will our classical computing algorithms on the security side will catch up?
Interesting question. So the first thing is, at the moment, in theory, classical computing can also break encryption, but it's just it would take years to do. So really, it's kind of sort of binary thing. Once the quantum capability exists, it becomes vulnerable. It's vulnerable. And really, the quantum association stops at that point, because really then you're into, well, what do we do about it?
Yes.
Because we know that could be vulnerable. And it's not in theory, right? We now see threat actors potentially stealing data, which is the so-called harvest now and decrypt later, the type of attacks that we're seeing. So that's reality. So this is not theory. This is absolute reality. And of course, as soon as that capability exists, which we think will be in 2029, then of course it is vulnerable, full stop, and that's it. So therefore what we see is organizations need to prepare for that, and really prepare for that cryptography challenge, because that's really what it is. So the good news is, at IBM we've done a lot of work on that. So the first thing that we've done in conjunction with being world leading in quantum compute development. We've also, in quantum cryptography, now developed through the competition that the NIST ran, the National Institute for Science and Technology in the US ran. They ran a competition to develop post-quantum resistant algorithms, cryptographic algorithms. And there are now 4 that have been declared by NIST as being available, and all 4 come from IBM. So we're very proud of that. We have those. So there is a solution where there are now post-quantum resistant algorithms available for organizations to be able to deploy. But Saji, it's not as simple as that. It's a more complicated journey that clients need to go on and organizations need to think about. So the good news is there are algorithms that are now available. The quantum capability is arriving by 29. Shor's algorithm will be able to be executed. So these things are pretty definitive. It's clear, it's set in stone, and it's about get ready now, really.
Awesome. One thing actually, which I always talk about, my audience is actually like that about what I cover, is the economics of systems. So with the quantum coming into the picture, the economics of systems will improve. And economics of systems and the security goes hand in hand. So if systems are not secure, doesn't matter how cheap they are, nobody will appreciate those, right? So shed some light on that, like how the quantum will solve the economics of systems, that things will get cheaper for us to do cheaper, faster, better computing at the same time keeping it safe.
Yeah, so I think that's a really interesting about how we see quantum emerging in this space. So I think the first thing is, as we see organizations adopting that spectrum of computing from CPU, GPU, and now quantum in that mix, their attack surface is going to increase, which is what's happening all the time now with AI, as we see right today. Quantum is going to introduce a new element, and whenever there is a new element of IT capability, in this case quantum computing, that attack surface now increases. So from a security point of view, we're already beginning to think about, well, what will that actually do in the ability for threat actors to also use that capability as it becomes available.
Sure.
So from an attack surface point of view, nothing new there. Organizations need to reassess where they are, reassess how they're going to be applying and using quantum computing, how that's going to accelerate a lot of their current compute processes and allow them to open up new frontiers in their businesses that perhaps they don't do today. So those considerations about how you risk assess that and how you bring that in, I would urge any organization when thinking if they're at the cusp of trying to adopt quantum computing, how they're going to do that. And we already see use cases in financial services playing out, for example. Life sciences, I mentioned before, those are areas where now that attack surface in terms of how quantum is going to be used is already being increased, and therefore considerations need to be taken around that. The second area really around that, Saji, is then, well, what about how we're going to see potentially that general purpose quantum computing when we get to that stage, if you want, being utilized by threat actors. So they're going to be able to run and manage processes in a way in which they can't do today. So again, that's another consideration, which I don't think we have all the answers for today, but certainly something here at IBM that we're thinking about.
Yeah, definitely, like how pervasive any technology becomes, and then the bad actors will flock there, at some point. Let's talk about taking quantum to the field, taking secure quantum to the field. Any partnership or alliances you folks are doing with any technology partners and or standards bodies? You covered NIST earlier a little bit, and or any regulators. So if you can cover these 3 sort of different stakeholders in your answer, that would be great.
Yeah, so in terms of quantum safe, which is the use case that we're really focused on, there've been the NIST we've had the competition, we've done that, but the regulators are now acutely aware of what's going to happen. We see the financial services regulators already right at the forefront of dictating a timetable for how organizations need to now prepare. We see also national cyber bodies like, for example, CSA and the NCSC in the UK and many others, ANSI in France, now dictating really a timetable for where critical national infrastructure, specifically financial services, energy, telecoms and other sectors, need to now be ready to be able to deploy quantum-resistant algorithms or have an approach to understand how they can migrate from their current cryptography into a place where they can assure the fact that they can run safely in a post-quantum era. And that really then relies upon a fairly in-depth study and understanding in organizations of what existing cryptography they're running. Remembering this is just asymmetric encryption that's going to become vulnerable.
Yep.
And that discovery piece, so we're working with many clients and with partners, so not just regulators and national bodies, but also with cryptography partners, because this is a broad ecosystem of cryptography to discover what organizations have today. Many organizations haven't had to pay a lot of attention to that area because it works, right? And it's trustworthy.
Yep.
In the future, as I said already, with quantum, that will change. So discovering what there is in an organization, how that works within their ecosystem and their supply chain, really critical. And then being able to apply the necessary action, whether that's replacing an algorithm with a quantum-resistant algorithm in a cryptography space, or encapsulating or providing a shell for existing crypt to run within that shell. That's another approach that organizations can take. So really mapping out what the response should be and then implementing that. So those three phases are really the way in which we see organizations needing to approach and then working with partners, be it crypt partners or national bodies, to ensure that we have the right ecosystem around us to take clients on that journey. So that's really how we're approaching it.
That's awesome. Actually, there must be when the regulators are coming to you folks, the industry tech leaders. They must be worried about the national security aspect of the which we hear all the time in the news. Yeah. In the case of AI now, right? So it's a sort of similar concerns. I can imagine they need to address to run the core infrastructure of any nation state. Now it has to be safe, right?
And here we are at MWC, and of course a big telco theme here. So really making sure that telcos, within the networks, can have the ability to be able to run quantum-resistant algorithms, which we're working with many of the leading telco providers to do that, and then make that available, obviously, from a transport layer into their customers as well. So that is something that we're doing, and we've done a lot with telcos at the moment to really help them understand how to walk through that journey. But I would urge anyone who's listening to this, get ready now, because this is a really here and now challenge of understanding what crypt you're running and where it is, and then mapping out a path of how to work out how to get ready for that post-quantum cryptography reality.
Yeah, actually, thanks for doing that. Actually, I was going to ask you the last thing. Thanks, Mark, for sitting with me. And if you have any departing comments other than what you just said to the audience, and get ready for what's coming down the pike. Any other remarks for anybody, like students entering the technology field? Look at the quantum carefully and where we are headed, and or the combination of classical and quantum computing, that it will give a lot of more opportunities to for new kind of roles and all that. So anything.
So I mean, I think it's a massively exciting time to be entering into the technology field. I think that a lot of the way in which we approach it is going to change now, especially with some of the AI tooling that we're seeing. So bringing it back to the here and now.
Yes.
The ability for us to now really create new software, new products, new services with AI tooling in a way in which we've never been able to do before. And in my world in security, it really changes the paradigm. And I think it's exciting because a lot of the stuff that we've done in security has often been quite labor intensive, quite manual in some respects. That goes away. So here and now today, it's a fantastic time to be entering cyber because you get to do the really interesting stuff now. Look at those really interesting attack vectors and how we can defend against them using some of the tooling that we have. And of course, threat actors themselves are using some of those tools against us. So it's a really interesting moment to be entering the cyber world and technology world more broadly. So it's a great moment.
Thanks, Mark, for your time and shedding some light on the very shiny object, actually, literally. And it's really a great timing, as you said, for anybody entering the technology field, and also for technology providers who are seasoned to take the leap into the next phase of computing, right? So along with AI. So thanks, audience, for listening, and stay tuned for more.